Hello there, welcome to Xerxez Solution. In our last session, we was discussing about the basic operators in Julia programming language, and we have seen almost all the possibilities of executing uh, operands using the fundamental operators. In today's session, we are going to discuss about another a very important concept called basic mathematical operations, where we are going to cover the concepts such as numerical conversions, rounding functions, sine and absolute value functions, powers, logs, and roots. In the end, we will try to discuss about trigonometric and hyperbolic function also. The complete document is available. Okay, so before starting the video, I recommend everyone to go through the documents. Okay, read the contents, then you can start practicing the mathematical functions using the Julia programming language. Let's talk about first what exactly the numerical conversation is. In Julia, the user gets three different form of numerical conversation. All the three differs in their handling of inexact conversations. Suppose let's say t of x you have one function, okay, or let's say you have converted t comma x. This notation converts x to a value of t. Okay, the results depends upon the following two cases here. Either the t will be in floating point type. In that case, the result will be the nearest representable value. This value could be positive or negative infinity. T again can be an integer value. The result will raise an exact error if and only if x is not representable by t. Next, you can have x divided by 3 t also. In this case, in this notation, we are going to convert an integer to x to a variable of integer type t, corresponding to x module 2 to the power of n here. Next, we'll try to discuss about the rounding function. Rounding function is the best example for this numerical conversations. Okay, let's straight away directly we'll try to discuss in the hands-on session. Okay, so already I have created my Jupyter notebook. You can see here in rounding functions, there are two techniques here generally we use in as far as Julia programming language is concerned. The first one is called a round method, and the other one is called the floor method. Suppose let's say you have a number or the sum of any operations. Let's say you got 3.8 and you want to give the round figure of this. Okay, so you can make use of the method called round. Okay, round, then you give whatever the results you get. Okay, shift and enter it. So you are going to have a round of what, the figure 4 here, 3.8, so which is near to a 4. Next, you can have you can display, since in our last case it is displaying in the floating point 4.0, 4.0, and suppose let's say you want to have the round of 3.8 to 4, okay, which is in the integer type. Okay, so you can make use of the method called int 3.8, and it is going to display only the 4 value. Next, there is another technique. Let's say you want the floor values, understood? So which is nothing but only the integer part you want to display. So I can make use of the method called floor. Okay, and it 3.8, and it is going to display you 3.0. Similarly, if you want an integer part, you can make use of method int of 3.8. Next, there are two more techniques generally we use. Okay, just like our round and flooring method called seal. Seal works just like you, okay, as like your floor method. Just like your round method. Okay, and both integer, if you want to display only the integer part, you can have, okay, with the method called int. Similarly, okay, truncation also will be there. So trunc, so it is going to display your the floor method here. Understood? So if you want the integer part, you can make use of the method called int. This is how, okay, generally we work with rounding functions. There are two techniques are available: round and floor, or you can go with seal and truncations. Understood? Next is let's talk about the other methods also, which are supported by the Julia programming language. Let's have, okay, you can make use of t comma x. This function will round x to the nearest the integer here, just now what we have seen. So all the documentation part is available, you can go through and you can explore. Okay, so based upon your requirement, based upon your the project also. And return type, already we have given type of x, which is nothing but the integer type here. Okay, t type of x, so on so forth. Next our topic is in mathematical function, okay, which is very important, called division. Okay, so division is very important, but as far as Julia is concerned, it supports for different method. We have different techniques generally we use, okay, to divide any number from, okay, as far as Julia is concerned. Now let's straight away let's dive into hands-on session. As far as divisions are concerned, we have the method called div, okay, division, and within the bracket you just try to pass the numerator as well as the denominator value. In my case I have taken, okay, 11 and the 4, so it is going to give me the reminder as a 2 here. Let's try to enter it. Similarly, I have given one more example. I have taken division 7 divided by 4, so I'm going to have, okay, the 1 here. Next is FLD we have. This is another technique. So it is going to divide and it is going to give you the reminder as a 2. In my case, FLD 11 divided by 4 I have taken, and the value is what I'm going to get is the 2 here. Okay, which is nothing but 11 divided by 4. 11 ones are 11 twos are. Okay, 11 12s are will come. So that means that 2 will be displayed here. CLD is it also support for floating point values. Okay, CLD may you can make use of here. Okay, so it gives you 3 here. Mode operation is also possible. It's Julia supports for mode operations. 5 mode of, okay, 2. Okay, so you can assign here 0 is to 2 here, so it going to give you the exact answer. Reminder, we have REM, okay, 8 comma 4, so we are not going to get any kind of the value here. Next is mode of pi. 7 asterisk pi divided by 5 have taken, so it will try to manipulate and it try to take the modulus of those number, and in my case I'm going to get around 4.3989 here. Okay, and division reminder, okay, so it is also possible. Division reminder, the other method is technique is also available as far as division in Julia programming language is concerned. FLD mode, which is again going to give you, okay, the reminders of two, then both the number 12 and comma 4. You can straight away calculate the GCD of a number. So I think this was one of the hectic. Even if you take C programming, those who are learning C programming, we used to write the very lengthy code, okay, to calculate the GCD of a number. But in the case of Julia programming language, there is a method called GCD itself. So just call GCD and give the numbers. Okay, so it gives you the exact the value of those two GCD of two numbers. In the same way, it supports for divisions. Okay, 1 by 3 floating point, 2 by 3, and it gives you the exact result. So in my case, okay, I have taken 1 divided by 3 and 2 divided by 3, and the result of the GCD is 1 by 3 here. Now we have LCM, so least common, okay, LCM also can be calculated in the same fashion how we are calculating the GCD of a number. Understood? So this is how some of the division techniques which are available in uh, the Julia programming language. And the entire documentation part is given in the documentary, so you can go through or explore all the options which are available in as far as division functions in Julia programming language is are concerned. Next, the next topic what we are going to cover in this mathematical operation is is sine and absolute value function. Okay, let's try to discuss how exactly the sine and absolute value functions are behaving as far as Julia is concerned. Next is, let's say absolute you want to inherit, okay, or let's say you want to take absolute value of okay, any number. In my case I can make use of the method called abs hyphen 7. Okay, so shift and enter it, so you are going to get us the value as a 7 here. Next, in the same way, it is also possible to calculate the absolute value of a complex number. In my case, I have taken 5 plus 3, okay, imaginary part. So it's going to give you the absolute value as 5.83095. Similarly, if you want to take the square of your absolute number, in my case, I have taken, okay, the minus 7. Okay, so it is going to give me the square of minus 7, which is nothing but the 49. Okay, again you want to say you want to take the square of your complex number. Okay, so as far as other programming languages are concerned, okay, so to take the square of complex number, we you need to write 10 to 50, 20 to 30 lines of a code. But in the Julia, okay, there is a particular method called abs square, and you give your complex number, automatically it will try to give you the exact result. Next, copy sign. There is another new technique method is called copy sign as far as Julia is concerned, which returns a value z which has the magnitude of x and the same sign as a y. For the vector presentation or vector data can be used this copy sign. 5 mine in my case I have taken 5 comma minus 10, so I'm going to get the value as the minus 5. Signs, there is another method called signs. Okay, so sign generally use uh, sign method is okay, so we have another method called sign. This function indicates the sign of x. It will return minus 1, 0 or plus 1. Okay, so you can see if it is true sine 5, so it is true, it is going to give me the value as a 1 here. Sign bit is also we have, so instead of representing in digit value like plus 1, okay, minus 1, 0, it give try to give me the result in a boolean expression. Flip sign also we have. Okay, so flip sign for flipping values, and if you check here, okay, it supports for both positive as well as the negative value. Next we have, okay, very important concept called powers, logs as well as the roots, okay, which are very important as far as any mathematical computation and programs are concerned. So as far as the methods are concerned, here we have square, CBRD, okay, for the cube roots, okay, hypothesis, okay, HYPOT, okay, to calculate the equations here. Exponential we have, okay, exponential m we have, okay, so on so forth. Let's try to explore some of the methods which are available in Julia programming language. First and foremost is, let's try to take the square of number. There is a method called square root, okay, sqrt. Okay, so I've given 49, so it should give me the square root as 7 here. Understood. Now in the same way, if you try for the negative value, let's say minus 49, so it is going to give me the error message. So it does not give you, okay, it doesn't support for the negative square number. Let's say if I've given the value as minus 49, so instead of giving, okay, so it doesn't give me the accurate uh, the value, so it is sending an error message. Next, cube roots also it is possible. We have a method called cbrt, okay, cbrt of 8, so we are going to get it as 2 here. Cube root of negative value also we can take, okay, minus 8 minus 2.0 I'm going to get here. Next we have log function. Log, in this case, log base 5 of 2 I'm going to take, so value I'm going to get is 0. Okay, 4306. In the same way we have significant numbers. Okay, so where you can divide the floating point. Okay, let me try to run this. So we are going to get it as a the value as a 0.186. Significant, you can try for the multiplication also. So once in my case I have taken 15.2 asterisk 8. Okay, so I'm going to get a value as a 15.2. Similarly, the one more the interesting point here, as far as Julia programming language is concerned, it even supports for trigonometric functions. Okay, algebraic as well as the trigonometric. Let's say differentiation and integration has made very easy here when you compare this one with Python programming language. Okay, let us try to discuss the list of trigonometric function which is supported by the Julia programming language here. So trigonometric functions like sine, cos, tan, okay, cot, next sine hyperbolic function, cos hyperbolic function, tan. Okay, so all this trigonometric functions are supported by Julia programming language. The same way you can go if you want to compute a trigonometric function with the degrees. Okay, then suffix the function with the d. Okay, as follows. Let's say cos sine 45. I can represent as a sine d 45. Okay, so d represent here the degree here. Okay, so you can explore all this. Let's try to run some of the functions here. So I want to take the value of cos 56. So I'm going to get a value of cos 56 as a 0.8532. Now let's say I want to represent with the degree cos d. Generally we use, okay, cos d of 56. I'm going to get it as a 0.55.9. Let's try with the sine also. Sine of 60 I'll have. Okay, and hit it run. So I'm going to get minus 0.3041. Similarly, sine of d. Okay, let's have 45. Okay, sine of d 45. Run it. Okay, so I'm going to get it as a 0.7071. I hope you are clear with the concept. If any questions, you can write the comments or the queries in the review box. Our representative will get back to you soon. Okay, let's try to meet in the next video lecture. Thank you. Thank you very much.